Okay, general addition law. It's fairly straightforward. It's going to be page 294 in your textbook if you need it. Right, so going back to some Venn diagram stuff. That's really nice and straightforward, I think. Right, so what letters are involved in A? That's going to be X and Y. What letters are involved in B? It'd be Y and Z. Not A and not B is actually just going to be T. A and B is going to be Y. And A or B is going to be X, Y, Z. Now the important thing is, like A or B, that is not the same as the everything in A added to the everything in B. Because if you look at that, I'm counting something twice. I'm counting Y twice, because if you look at Y's in A and Y's in B. Okay, so if I was to do this, if I was to do A or B, yeah, I need to do something else here. And what I'd need to do is I'd have to subtract the A and B section, which is going to be the Y. Now, using that information, can you please do this question here, please? Just to be clear, the 19 in M, that's all of it is in M. Right, now there's not much I can fill in to begin with, but I can fill out the outside, which is 5. Now, using the thing that I just know, I know that if I add everything in M, and then I add everything in B, yeah, we've got 19 plus 17, I get 36. Now, that's already a bit of an issue because there's 32 in total. Yeah. So actually, but what I also need to do is actually have to add in the people on the outside as well, which means that it's 5, which means I get 41. But again, you've got to think, I've added everything in M, yeah, and I've added everything in B. Okay, so that middle section I've counted twice. Okay, I've also counted out the outside. That middle section I've counted twice. So that 9 that I'm over actually tells you that my middle section here is 9. Okay, and that's how we work out that. It's so important. Yeah. And of course, when your middle section is 9, everything else falls into place because I know this is now going to be 10. I know that my B is now going to be 8. Okay, now it's a very complicated question, this, but it is really simple. So on this Venn diagram, this is A or B. Okay, now I just want you to write a different expression for A or B. Yeah, and you can use, like, I don't know, the section of A plus the section of not B and the section of not A or B. Now, start off with the probability of A plus the probability of B. What else do I need to put in here to give me exactly the same as a section of A or B? Give you a bit of time to think about that. Now, as I said a few times, but if I acknowledge the probability of A, which is all of this, which for some reason I've done blue pen, and then I acknowledge the probability of B, okay, which is all of that, I've counted that middle bit in twice. So what I need to do is I need to subtract that middle bit. And that middle bit is the probability of A and B. And this is your general addition law. Yeah? Probability of A plus your probability of B minus your probability of A and B is your probability of A or B. Okay? It's in the top right hand side if you actually want to use it. Write it down, you need to know this. But if you just draw things in a Venn diagram, sometimes things like make sense. So let's have this question here. Yeah. So I just found this off the internet. Probability of Sears Tower, if you go to Sears Tower, is 120 out of 200. Probability that you go to Wrigley Field is 100 out of 200. Okay, and the probability of both is 60 out of 200. Okay, so what I want you to do now is I actually want you to find out the probability of you going to Sears Towers or Wrigley Field. Use a formula so you can do it. Okay, I've drawn the formula. I've drawn a Venn diagram out for you. And again, it's easy with a Venn diagram because I know if I do 0.6 plus 0.5, which is this bit here, okay, I've counted my middle section in twice, so I need to subtract my middle section, yeah, to get 0.8. So there's a 0.8 chance that you're going to see one or the other. Another one, a bit more mathematically based now. Probability of A is 0.5, probability of B is 0.2, and the probability of A and B is 0.1. What is the probability of A or B? So to do this, you do 0.5 takes the probability of A plus 0.2 because that's probability of B minus 0.1 gives 0.6. Nice and straightforward. Here's a worded question for you to do. Have a read, see if you can do it. Okay. Now what we need to do, we need to get like the information out of this. Yeah. So before I attempt these questions, I'm going to write my probabilities down. So I'm doing the probability of someone being ticketed. I'm going to write the probability that somebody's not ticketed. Probability of a man and probability of a woman as well. Okay. So probably a man is 50 men out of 82, and a woman is 32 out of 82, okay, which is nice because out of 100. Probably a ticketed is 47 out of 82, and probably they're not ticketed is 38. So a man of someone who is ticketed, okay, for that one now I'd need to do probably a man, which is 50 out of 82, plus probably it's somebody ticketed, which is 47 out of 82, minus them both, which was 39 out of 82. Okay, my answer is 58 out of 82. Now, probability of a man of someone who was not ticketed, and we know the probability of a man is 50 out of 82, and probability of not ticketed is 32 out of 82. The probability of both happening was 11 out of 82, which is 74 out of 82. Last one, a woman or someone who was ticketed. Right, so a woman is 32 out of 82. Person ticketed is 47 out of 82. And the both happening was 8 out of 82. So that means that it's going to be 71 out of 82. Okay, there you go. This is a fairly straightforward topic. Just break them down. Write down your probabilities if you need to.